number one job and problem like this would be to solve for y on this and this equation. Take just a second to do that, because if you're going to graph it, you'd need to solve for y. So take a second. Solve those for y. And then you'd know the y-intercept. You'd know the slope. Take away x on both sides. And this one, cool. From there, it'd be easy, wouldn't it? You'd be able to start at 250 and then have the slope go down 1 over 1, down 1 over 1. You know? And here you'd start at 350 and you'd go down 2 and over 1. And then that's one of the key skills. Another key skill is actually writing an equation like that. I want to take just a moment and tell you a story. I want you to write an equation. X is going to be adult tickets, and Y is going to be student. If I said we sold 500 tickets, you already can write an equation. X plus y equals 500. What if instead I said we sold at least 500 tickets? At least 500. Greater or equal to 500. All right. Now, a ton of kids got, literally, there was at least 12 kids that got this wrong. What if I said we sold twice as many adult tickets as student? Right? Don't say it. Write it. Use X and Y. We sold twice as many adult as student. I didn't say at least twice. I said twice as many adult as student. So my advice, make it y equals x, because isn't y usually on the left? Y equals, right? Isn't that a better way to do it? And then think twice as many adult. It's counterintuitive. You don't do 2x, you do 2y. Why? Because the y is smaller. The students, they're smaller. There's a smaller number of students, so you've got to double them to make it equal. All right. And then if it had a less than or equal to instead, it'd be really complicated. You got to figure out which way to make the sign go. But just think it through really carefully. All right. So what else is important on those? A ton of you, when we had this kind of a question, we had it all shaded in, and we said, what's the max profit? A ton of you picked that spot. Why not? Why can't you pick that spot? It's not feasible. All right, good. So you can only pick the corners. It could only be here, or here, or here, or here. And I can't tell what the max is going to be just because this one looks tall, because I haven't told you what makes more money, X or Y. Okay, so let's say X's make us $5. For each X you sell, you get $5. And for each Y, you get only $2. So let's say this is at 8. This is at 5, 5. Let's say this is at 7. Write the optimization equation. This is for profit. And then figure out which makes you the most profit. $5x plus 2y Then I write my 3 points, 0, comma 8, 5, comma 5, or 7, comma 0. Zero comma 8 would get me $16. 5 comma 5, $35. And 7 comma 0, ooh, $35. Trick question. Which one makes the most profit? It's a tie. 5 comma 5 or 7 comma 0 both make $35 of profit. That makes sense to you? Okay, that's one unit, and we have to make them really short, right? Because we've got a ton of units to go over. So then the next kind of question I want to talk about is in matrices world. Remember these guys? All right, so let's do a quick review. Everybody take a second and get your calculator up. If you don't have one on your desk, get the single sign-on one going. If anybody doesn't have their iPad today, I have a calculator you can borrow. All right, just to start with, if I had a 4 by 2 and a 2 by 3, would it multiply or not? Yes, and the answer would be, don't say it, write it. What would the answer be? Yeah, it works because these two match, and it would be a 4 by 3. Raise your hand if you knew that. Okay, good. That's multiplying. Now, if I had a 4 by 2, that's going to be like really complicated to put in. Let's just put in 217. Put in that matrix on your calculator. Well, first off, you'll have to know, is that a 3 by 1 or a 1 by 3? Well, it's always rows then columns. RC, like remote control. And how many rows does this thing have? 3. By how many columns? 1. So that's a 3 by 1. Put that in your calculator, and let's call it matrix A. What if we were timesing by XYZ? Not going to put that in your calculator. Wouldn't even allow you to if you tried. Don't type this in, just listen. If this was matrix B, generally, wouldn't the technique be that you should do inverse A times B? Do you remember that deal? To get A out of here, you do inverse A, and then you do it on both sides. But what would the problem be here? You'd have to multiply that times that, and they're both 2 by 1 matrices, or sorry, 3 by 1 matrices. Do you get a 3 by 1 and a 3 by 1 wouldn't really multiply? So we wouldn't have set that up. We're not going to make everybody super confused on the test. But do you get that not every matrix can multiply? All right, so I'm going to set up one that would work. But before we're done with this matrix right here, which was a 3 by 1, would you try to get the inverse of it? That would be A to the negative 1. Is it possible that there is no inverse? Yes, that is possible. Was there an inverse? Oh, okay. Because do you remember that deal where we had to do inverses by hand? All right, now I'm going to have you put in a new matrix. This one, we're going to make it 2, 1, 4, 8. Now it's a 2 by 2 matrix. Put that one in your calculator. If this is matrix A, and it's a 2 by 2 matrix, now, do you remember that deal? Let's stretch your memory a little bit, where you do the flip-flop, op, and then some kind of fraction in front of it, and then you could get the inverse. Don't use a calculator. I know you could do that. That would take you half a second. Do you remember what it does, though? Because it involves the determinant, and it involves flipping, flopping a couple spots. And let's see if you remember this. It looks like this. All right, let's do this determinant part. You probably remember there's a subtract in it, right? But is it 2 times 8 minus 1 times 4? Or is it 1 times 4 minus 2 times 8? Do you think I should start with 2 times 8? Raise your hand if you think I should start with 2 times 8. All right. And that kind of makes sense, because wouldn't you start with the upper left-hand corner? Like, that kind of makes sense to me. The first number you would touch would be 2. All right. So then, minus 1 times 4, which is 4. So that's 16 minus 4, which would be 12. Do you get that this number is a real number? What if that number had been 0? Do you get how that makes it impossible to do, as if the determinant is 0? Okay, good. So now, flip-flop, op. The 2 and the 8 flip-flop. 8's here now and 2's there now. Op means minus 4 and minus 1. And cool. I did it in my head. This is going to be 1/12. So everything has a divide by 12 in there. And those could simplify, but there is how you do an inverse. But we might make you do one by hand, but we will for sure need you to be able to do one with the calculator. Take a second, do a to the -1 on the calculator, and we'll verify that I did it right. And then remember that deal where you had to make it be fractions? Once you have your answer in on the calculator, make it be fractions. And mine have to be reduced, but they should be the same. Like 8/12 would reduce to 2/3, right? All right. Can you verify, did I do it right? Cool. All right. Now, how could we actually use this in an equation? If we had a system of equations that was like 2x plus 4y equals 12 and 1x plus 8y equals, let me think for a second, 6. Do you know how to make the rest of the equation? I had made it nice so that our A matrix doesn't have to change. Our B matrix, you got to figure out. And you got to figure out where X and Y go. And then you'll have to use the inverse of A thing. I want to see, this is supposed to be a review. Let's see if you can do it without me. When you're done, you're going to know the answers are like, 7 and 0 or something like that. Figure out what the answers are, compare with the kid next to you. I'm going to pause for a second, let you struggle a little bit on your own. All right, should have put an X here and a Y here, and then should add a 12 here and a 6 here. Check with the kid next to you, see if you got the same thing. All right, so I think you get 6 and 0, which means x is 6 and y is 0. Raise your hand if you had that one right. Awesome. And if you don't know how, if you're at home and you're like, how'd they get that? I did inverse of a on both sides. Inverse of a cancels regular a. This is gone. Technically, what it turns into is this thing called 1, 0, 0, 1. You remember what that's called? Starts with an I. The identity matrix. Now, you don't have to show that in your work, but when you multiply two things that are inverses, you don't get nothing. You get the matrix version of 1, which is that. Then the answer really comes about from multiplying these two together. Inverse of a times b, and that came out to the 6, 0. All right. Cool. There's a review of another 2 chapters. So now we still have Wednesday and Thursday to get you ready. Why am I not saying Friday? Because you have to take your finals for hours 1 and 2 classes on Friday. So we only have 2 more days left. All right. We'll get a bunch more done, but this should get you on the worksheet up through... you know what? We should do one more so we can finish the page. Let's talk about this kind of probability. We'll just do one last thing. Remember the circles, Venn diagrams? Let's just talk about those so we can get to the end of that page. Well, these have a cat only. These have a cat, but it's a cat and a dog. These have a dog only, and these don't have a cat or a dog. All right. So usually these are just combinations where you're like, well, what's the probability of this given that? Well, if they say that, for instance, you have a dog, given that you have a dog, then you only use these numbers. You have to use only those numbers because they said given you have a dog. Then what's the probability you only have a dog? Well, it would be like 0.26 out of all of these added up. All right.
If you have a dog.
Oh, you're right. If you have a dog, you wouldn't include the 0.4. Sorry about that. It would only be those two. So then, given you have a dog, what's the probability you only have a dog? It'd be the 0.26 over these two added up. All right. Just look at what the next page has. Some more probability stuff. Can I go further into that? Let me see. No, I think we can be done. All right, get up through problem 38 today, and I think you'll be in a good place. That's all I got for you for today. I feel like if I don't go far enough, I won't finish this thing.